Hi, everybody. Yes, from Canada, so if I have a bit of a different accent, there's a bit of French in there, and I apologize ahead of time. I'll talk a little bit slower and try to keep myself clear. Formerly, myself, I used to work in technical documentations, technical training for Bombardier recreational products. We encountered several different problems holding us back in terms of creating efficient documentation to support the products. It ultimately led me to meet Phil, and we're here to show you what we've come up with.
My name is Philip Taylor. My background, I'm the technologist in the company, building the technology, handling, making sure everything works as it's supposed to. My background is actually the film visual effects industry. I worked at Autodesk, companies like Softimage. I worked on crowd simulations for battle films. But yeah, getting into this space, it's all about making it easier to document products, and it's a really exciting space to be in.
Before we get started, a big thanks to Develop3D for having us here. So the format of our presentation is we want to take on 3 myths that I was really facing, that I lived through the entire time of technical publications, technical training, and kind of debunk them. So the first one, that desktop apps are faster than web applications. We know that when we want to publish something, it needs to be on the web, right? Whether it's a PDF you download from a link on the website or actual interactive 3D documentation. As a technical publication professional, one of the first things that we do is we always want to load the full model. It takes a long time, and when you say that I want to load the full model in a web application, it creates a bottleneck. You just can't kind of see your way forward. Leave it over to Phil.
So, what's interesting, when we founded the company, we're really focused on this challenge of how do you handle really large models? What's interesting about this time in history is that lots of things are changing around us. So web browsers are getting more powerful every year. That's certainly something that's moving really rapidly. The GPUs, the hardware that we render stuff on, is getting much more powerful. So even your mobile devices today are as powerful as laptops just a few years ago. So when you see these two technologies changing, you realize that there's new opportunities to change the way you, say, publish content online. And 3D is just the main mechanism that we're exploring. So this is an example of a model that we handle in our browser. This is a piece of mining equipment from a company called Portafil. It's made up of 17,000 parts, 10,000 unique parts. So that's 10,000 different base 3D models. And this is all loaded relatively rapidly in the browser, and you can rotate this on sort of any sort of basic piece of browser, even a tablet or a low-end laptop. So this was kind of our objective. Can we make it possible to put those large, complex models in the browser and make them usable by sort of anybody out there who might need to look at this data?
So if we move forward to the next myth, I'm sure you've all seen illustrations like this, right? Where the best practice in technical documentation is the idea of less is more, right? You want to promote content reuse. So what you do is you strip away all of the context that adds the necessary information around the product, and you document only just that one product. I have a particular story where you reuse parts across all vehicles. And back in 2014 or 15, we were introducing a new Spider. It's the 3-wheeled motorcycle that BRP produces. Same fuel pump as other ones, but now it was in a different fuel tank on a different vehicle. We had to recreate our entire section for the fuel system because we were showing the right fuel pump, but in the wrong tank on the wrong vehicle. What does technical publication do to fix this? Well, you create a general exploded view at the beginning of the section to kind of name all your components, illustrate where they are in space, but then create reusable chunks to use across all your manuals. Problem with that is that's not how tech pubs first approach the vehicle, and it's not how your users first need to consume the information. They want to know what bolt is there. They want to know that if you pry something away, it'll give you that clearance. Again, back to Phil here.
So the challenge with visual content is that it's difficult to update. So authors get penalized for using visual content in the documentation because they sort of are struggling it's a complex problem to then update or keep it aligned with, say, as models change. The problem is not that the fuel tank was there. The problem is that it wasn't the correct fuel tank in this case. So how can we make it more possible to use that visual content? Because if you remove visual content, you've got to compensate with something else. It's either more written content, which offloads the problem to translation services that need to update their content. So, and consumers in general are going to respond better to more visual content in their documentation. So we want to make it more easy or easier to use as much 3D content as you can and still make that process manageable and at scale.
So if we go forward to the last one, we talk about making updates to this. And I'll piggyback on what Phil just said, scale. Right? At Bombardier Recreational Products, we had over 630 different SKUs just of snowmobiles. We had on-road, off-road vehicles, we had boats, we had jet skis, we had everything. We're delivering this to over 30,000 people just in our internal and partner network. So that includes internal stakeholders at the company and dealers, distributors, et cetera. And then you multiply that again a few times to get to the total sort of end user base. This was in 12 languages. And you could just kind of see the scope compounding and compounding and compounding. So updates suddenly became really complicated. Here, just a quick little caveat. I'm not talking about updating the illustration there. Everyone knows that you can move a callout around. The problem was, where does that illustration reside to your end network, right? Like, what changed? What was your input change? Was it a CAD file, a part number? What changed? And then how many different documents do you need to update following that change?
So using 3D visualization is an interesting technology because basically what it's doing is it's taking some sort of inputs and producing images dynamically on the fly. So you're able to generate images when you need them. It's not a silver bullet. If you stick a 3D visualization in a PDF, you've still got the same update challenges. Those PDFs need to be updated at some time. And one of the challenges is when you start putting all your parts and systems into one large 3D model, how do you facilitate that updating over time? So one of the core tenets of our platform that we've been developing is that we manage the 3D data in the same way that your CAD applications do. So in a CAD application, you've got individual parts which are put together into assemblies, and those assemblies are put together into bigger assemblies. So you've got this big tree structure. And what you want to do is preserve that structure, because that structure is the way the designer has created the data. It's managing the complexity of the scale at scale. And you can reuse components like that. Fuel pump will be used in many different vehicles. It's the same exact fuel pump in the PLM. It's just been put into different assemblies. So when you start thinking about 3D, what you don't want to do is kind of bake that fuel pump into each assembly it's being used in, because that just creates another update problem later on. The way our platform works is that the fuel pump is documented on its own, and wherever it's being used, that fuel pump is the same exact fuel pump, but it's being used in different assemblies. This is key to, as you transition to 3D, to not create another problem, which is how do you manage it at scale? When you've got literally hundreds of thousands of parts and you're documenting all of those parts, you need a system that understands the data structures that you're feeding into it, and then can facilitate publishing and updating that content over time.
So what have we done that's different? In a nutshell, we can piggyback on what Phil just said again. We maintain that file structure assembly, and we're presenting this in a platform that can then include all the cloud tools you need to create your technical illustrations, spare part catalogs, and content. Basically, the vision, if you had to paint something in your head, and what we want you to leave this with, is imagine that your 3D model becomes your table of content for all your after-sales technical documentation. If you're interested to see how this works, come by, check us out. Booth B57, it's downstairs beside coffee. Thanks a lot, guys.